All right, guys. So I did find an error in my equation. As I was starting to calculate the B0, the y-intercept, this would be impossible. I'd have to know a y hat and an x value that corresponds to it. And so I looked back and I realized that I had written the equation down incorrectly. So let's please go back to this and correct it. So it should be y bar and x bar right here, right? Y bar and x bar. So that means that we're going to go back into our calculator. We're going to go back to our two variable stats, and we're going to write those values down as well. All right, so please, if you would go back and correct this equation. So to find B0, it's y bar minus B1 x bar. So we're going to go back to our calculator. I'm in two variable stats. If you've forgotten how to get there, it's stat calc, two variable stats. And I'm going to go ahead and write down my x bar and my y bar. So x bar is 70.5 and y bar is 11.292. All right, so B0 is 11.292 minus our B1, which was right here, 0.3769 times x bar, which is 70.5. And let me just double check that I'm not off the screen. Yes, I'm off the screen. So I'm going to go ahead and do that with my calculator. So 11.292 minus 0.3769 times 70.5. So this gives me negative 15.279. And now that I have both of my pieces of information, I can write my equation of the line of fit. So my equation of the line of fit is y hat equals B0, which is negative 15.279 plus B1x, and B1 is 0.0317, or sorry, 0.3769, don't listen to me, and then times x. Now, once we've written our equation, we always either have to define y and x, which a lot of students are bad at, or replace y with what it represents and replace x with what it represents. So y was our height, or sorry, our shoe size, and x was our height. So you could say where y hat is the predicted shoe size and x is the height, but then you have to say of AP Stat Boys, and this generally is more complicated, right? But they do want us, if they want us to define our variables, we would say this. Okay. Conversely, we could write instead, since y is the predicted shoe size, we could say shoe size hat equals negative 15.27 plus 0.3769, and then write, I'm going to run out of room here, but height. So times height. Okay, interpret the slope of the line in context. So we talked about this a little bit last time, but here's my slope right here. So what I do is I always put this value over 1, and remember that this is delta y over delta x, and y represents shoe size and x represents height. And our units, we must use units, right? So we'd say for every 1 inch in height increase, so for every 1 inch increase in height, shoe size is predicted. Always we have to use the word predicted or expected and then in this case it would be increase since this is positive. If the slope were negative, it would be decrease. To increase by 0.3769 shoe sizes. Now shoe size is its own unit. It's a measure. So we could say in male shoe sizes, but this would probably be sufficient. Okay, interpret the y-intercept of the line in context. So our y-intercept is right here. And so interpreting that in context, the y-intercept of negative 15.279 indicates if a boy had a height of 0 inches their predicted shoe size would be negative 15.279. Again, in units, there are no units on shoe size other than shoe size. This makes no sense in context. So I always follow up. If it's an unreasonable interpretation, nobody would have a height of 0 or a negative shoe size. However, if they asked me to interpret it, I would. All right. Next it says predict the shoe size of a boy who is 71.5 inches tall. So this is our X value. So we're going to substitute it into shoe size. Right, predicted shoe size equals negative 15.27 times 0.3769 times the height. So I'm going to substitute in the height of 71.5 inches. So the predicted shoe size is negative 15.27 times 0.3769, and then 71.5 is our inches. And use your handy dandy calculator. Negative 15.27 plus, I'm sorry, that should be plus. I don't know why I wrote times. I'm going to go back and fix it. Plus 0.3769 times the height, which is 71.5. So this person would have a predicted shoe size of 11.678. So if we wanted to predict it and then say it in context, a boy who is 71.5 inches tall has a predicted shoe size. Oops, predicted. I went off the page, but shoe size of 11 point, I guess we could round that to 11.7 according to our model. According. So we predict that somebody who is 71.5 inches tall would wear between a size 11.5 to 12 inches. Okay. Could we use this model to predict the shoe size of a female in the class? No. This model is for males similar to those in AP Stats. Males similar to those in AP Stats. to now put a girl into the model would potentially change our model. Oh, goodness. I've been off the screen. I apologize. Okay, I'm going to kind of go back through. So we had shoe size equals negative 15.7. This should be plus, or 15.27 plus, right? Our 0.3769 times the height. I went ahead and calculated that, and I got 11.678. And then again, no, this model is for males similar to those in AP Stats. A boy in the class who's 64 inches tall. So let's take a look at our scatter plot. And so our data for height went from 67 inches to 77 inches. And so what we would be doing if we were to use 64 inches, well, 64 inches would be 3 inches below anyone else in the class. And so that's called extrapolating beyond the data. So we say no, our X values were from 67 inches to 77 inches. Since 64 inches is below, and it's quite far below our, our lowest observed X values. This would be extrapolating beyond extrapolating beyond the data. So that's another important word. It didn't come into play in our vocab yet. I believe it's in chapter 9. Don't quote me. I'm going to go ahead and look. Yes. So chapter 9 introduces extrapolation again, but I'm going to introduce it here because I think it's an important concept. All right, let's keep going. What is the residual value for the tallest boy in the class and the residual for the shortest boy in the class? So let's go ahead. I'm going to put the equation back up on the top of the page. So it was shoe size equals negative 15.27 plus 0.3769 times the height. All right, the tallest boy in the class. So the tallest boy in the class would be the person who was 76 inches tall. So he had an actual shoe size of 13.5. So we're going to calculate what his predicted shoe size should have been. So when it says the residual value, to find the residual E, we're going to take the observed Y minus the expected Y hat. Well, I know the observed for the tallest boy in the class. What I need to know is the expected. So to find that Y hat, I'm going to put for a T right here for the tallest boy, equals negative 15.27 plus 0.3769 times height, and he was 76 inches. So we're finding the tallest boy's predicted shoe size. And so his predicted shoe size is negative 15.27 plus 0.3769 times 76. His predicted shoe size is 13.37. Now his actual shoe size was a 13.5, so he's pretty close to the line of best fit. So his error, right, or his residual would be, so E sub T for the tallest boy, Y, which he actually wore 13.5, minus 13.37, which gives me 13.5 minus 13.37, 0.13. He's just slightly above the line of fit. All right, let's do Y of the shortest person in the class. So Y hat is negative 15.27. Oh, I'll put an S right here for the shortest boy in the class, plus 0.3769. And we're going to go back and look at who was the shortest in the class, which is this individual, 67 inches. And he did wear a size 10. So we know what his actual Y value was, but we're trying to predict what was his predicted shoe size. So he was 67 inches. And so that's negative 15.27 plus 0.3769 times 67, which is a 9.98. And so again, the expected, or right, residual value, oh, not for the tallest, my bad, for the shortest person, was his Y value, which was a 10.5, minus 9.98. 10.5 minus 9.98 is a 0.52. So then it says, how good was the model at predicting these? Well, they're both actually pretty close. So the model was pretty darn good. It was better for the tallest, but still both are small residuals. All right, so it says, which student had the largest residual value? All right, at this point, because we sketched in our line of fit, I think it's this person right here, the person who was 70 inches and wore a 12.5. But because we sketched it, I'm going to go ahead and show you how to make sure that you have your line of fit in your calculator. So the first thing that we do is we enter our data in list, which you already should have done, list 1 and list 2. And then the next thing, I just cleared that out, right? So the next thing we do is go to Stat, Calc, and go to LinReg number 8. Again, I've already done this, but I'm going to do it again with you guys. So Stat, Calc, LinReg number 8. My X list is list 1. My Y list is list 2. My frequency list, just leave it blank. And I'm going to store my regression equation. And just a reminder, you have vars, Y vars, and you hit enter twice. And then you hit enter one more time to calculate. And you can calculate your line of fit. So you can see that our equation, the negative 15.27, and then the slope of 0.3769 is really, really close to theirs. And our R value, right? And then our R squared value. But I want to see on their scatter plot who had the largest residual. So you go to stat plot, second stat plot. Make sure only the first plot is on. We're going to choose that scatter plot right there. List 1 and list 2. You can use whichever mark you'd like. I can change my color, but I'm just going to leave it blue. Now, you're going to hit zoom 9, and it will draw in the line of fit. And so I just want to illustrate to you guys the shortest and tallest boy in the class. The shortest and tallest, they're very, very close to the line of fit. And it says, it looks like to me this individual right here indeed was the person that was most off the line of fit. It looks like that person had the largest residual value. And that was the person who did wear a size 12.5 and was roughly 70 inches. But it looks like it could almost be tied with this guy right here, which was the person who was 73 inches and wore a size 11. So because they're both really close, I'm going to calculate both of those. So in my data, I'm going to go back and highlight who those people were. Where's my highlighter? Here it is. All right, so the first individual we think is this person right here, who was 70 inches and wore 12.5. And the other individual is the person who was 73 inches and wore a size 11. And since they're both kind of close to being the farthest off the line, I'm going to check both of them. All right, so let's do some calculation. So the residual value, E, I'm going to say for the person who was 70 inches tall, is his actual, which was a 12.5, minus his predicted. So I'm going to calculate his predicted off to the side, which is negative 15.27 plus 0.3769 times his height, which was 70 inches. So this is 11.113. And so his residual value is 1.387. So he's almost 1.5 shoe sizes above the line of fit. All right, I'm going to redo this with the gentleman who was 73 inches. He wore a size 11. I'm going to find his predicted again by plugging in his height. And so this is 12.244. 11 minus 12.244 is negative 1.244. So this individual is about 1 1/4 shoe sizes below the line of fit. So this was indeed the largest residual. He had the largest residual, and explained, so 2 ways that you can explain it. Well, first I used my scatter plot to determine that there were 2 possibilities. These 2 individuals were the furthest away from the line of fit. This individual was above the line of fit, and we found that that is his E, right? His E was Y minus Y hat. And this individual also was far off the line of fit, but it seemed a little closer. His E, again, Y minus Y hat. This individual's residual value was just slightly higher than this individual. And I can tell that by calculating each residual value. By technology, view the residual plot of heights. Describe what you see. All right, so we've not done that before. Let me see how long we are on the video. Yep, I'm going to stop here and break this into another video. So pick it up on the next one, guys.